In this video, what I would like to do is talk about what a position vector is and how we can find it. So a position vector is a fixed vector that locates one point in space relative to another point. A lot of times it's very convenient for us to choose the origin as the point in space we want to locate something with respect to. So the origin is going to have, in 3D space, is going to have a point of 0, 0, 0, 0x, 0y, 0z. Now let's say we have another point over here, and this is point P. Point P is going to have some, with respect to the origin, it's going to have some x, y, and z location. So we go some distance along the x, some distance along the y, and then some distance along the z, and we can get to that point P. The position vector would be that position that relates the origin straight to point P. So that position vector, we'll call this R, is in 3D space. In more general terms, let's say we're not relating something to the origin. We have a different reference point we want to relate something to, and we are going to call this point A. And we want to relate point B, which is over here, to point A. So our position vector is going to be like this. Our position vector R relates point B to the point that we know, which is point A. And in this case, let's relate point A to our origin. So this is R sub A. And let's relate point B to our origin. And this is RB. So these are two position vectors. This is a position vector between A and B. And if we write this out, if we do some vector addition, we have RA, so that position vector, plus R is equal to RB. And we can trace this just to verify this is right. If we go RA and then we add R, we get to this point RB. Okay, so now we know RA, we know RB. We're usually going to be looking for our position vector R. So our position vector R is going to be equal to RB minus RA. And this is going to be, RB is going to be the head of our vector, the head of the position vector, minus the tail of the position vector, which would be RA. So if this point A, it has a point AX, AY, AZ, and point B right here has a point BX, BY, BZ. When we subtract these 2 points from each other, we'll say our position vector R is equal to BXI plus BYJ plus BZK minus AXI plus AYJ plus AZK. Now we can combine like components. So our position vector R is going to be equal to BX minus AXI plus BY minus AYJ plus BZ minus AZK k. And all we're doing is subtracting the x components from each other, the x components of b from the x components of a, the y component of b from the y component of a, and the z component of b from the z component of a. And if we go back and we look at this, the first example we looked at, our tail is at point 0, 0, 0. Our head is at point x, y, z. So our position vector r is going to be equal to this x minus 0 I plus y minus 0 j plus z minus 0 k. And because it's 0, it just goes away. So we have xi plus yj plus zk. And that's exactly what we showed here. This is my x vector, xi. This is my y vector, yj. And this is my z vector, zk. So this, what we showed, it still holds with this general case. Now let's look at an example. What I want to do, I want to find the position vector that points from A to B. Okay, so the first thing I want to do is I want to list out the points of A and list out the points of B. So my point A is going to have a point of, this is x, so I'm going to be 5 along the x. I'm going to be 0 along my y direction. And I'm going to be 0 along this z direction. So all I need to do to get to A is go 5 along my positive x. Okay, now let's say what B is. So for B, the first thing I need to do, in B is actually, it's located on this plane right here. So B is going to be, I don't need to go anywhere in the x direction because it's located on this plane. So I'm going to go 0 in the x. I need to go over 3 in the y. And then in the z, I need to go down. This is my positive direction. So I need to go down 2 in the z. So I'm going to go minus 2. So that's my point A and that's my point B. Now this position vector, and let's label it, this position vector r right here. So r is going to be my position vector of B minus my position vector of A. And this just happens to be the same equation. This is going to be where my head is, the point of the head. This is going to be the point of the tail. And if we use that equation we just had, we're going to have, this is going to be equal to 0 minus 5i plus 3 minus 0j plus minus 2 minus 0k. Simplifying, we get minus 5i plus 3j minus 2k. So this means in order to go from A to B, we're going to have to go minus 5 in this direction, minus 5i. We're going to have to go 3 in this direction, 3j, and we're going to have to go minus 2k in this direction. So we were able to check that our position vector right here is correct. If this video is helpful, please consider subscribing to my channel. Please consider liking the video. It helps make my videos more visible.